Okay, hello everyone. Let us try to understand programming by analyzing this worked example, whereby we shall analyze this program line by line in order to understand the runtime behavior of a program. As you can see, line number 1 is a library, and this is a standard line which will have to be in all of your programs in order for the compiler to supply you with facilities which will enable the computer to understand each line of code that you are going to write. Line number 2 is just another library, as you are going to see. You will have to use it in most of your programs. Line number 3 is just a standard code which supplies you again with some capabilities for the compiler to understand your program. Now, what you see in front of you in line number 4 is the line that has the statement int main. This is a header of a function, and the main is a standard function in C++ such that you cannot write any program in C++ without using this particular header. So this main function now starts from line number 5 with this open curly bracket, and it ends at line number 14 with this closing curly bracket. This, as you can see, is something like a paragraph. Now, the entire logic of this program will start to be understood if we analyze what is happening in line number 6, because actually here is where the program execution starts. Line number 6 and line number 7 and line number 8 are declarations. This is where variables are being declared. Declaration of variables. What does declaration of variables entail? This is where you are telling the computer, you are commanding the computer to create spaces where you will have to put your data. So, if we assume now that before the running of your program, the computer has got billions of spaces which are free, waiting for you to book part of it so that you can use one or part of that space for your program. So you have already come to the free space of the computer, and now you are telling it to reserve or to book a space, one of the spaces in its free bank of spaces, so that you can put your data there. And you choose the name of that particular room to be X. So after line number 6 is executed, this particular scenario will change such that at this particular space, which was free, now you are reserving it. Reserved. You are reserving it, and you have called it X, while the rest now remain free. The rest remain free, and here is free. So with this line, you have reserved one space in the computer, which you have called X, and you will use it to put data inside it. You can think of this with analogy of a bus. If you go to the bus company and you reserve a seat, then these people will show that the seat number X is already reserved and nobody else will acquire it, while the other seats are free, waiting for someone else to book. So when the computer comes to line number 7, int y, another space from free spaces of the computer is reserved. Now we can say that this particular space is changing such that this is the first reserved, that is X, and now you have already reserved another space which is called Y, reserved, and the rest remain free and free. That is because int y has caused this scenario to take place. Mind you, in the beginning, the entire space of the computer was free. When you commanded it with int x, then you reserved one part of the free spaces, and when you commanded int y, then another space has been reserved for your use as a space where you are going to input data. So when the computer comes to line number 8, the change which is going to happen is that instead of having only 2 spaces now, you have 3 spaces which are reserved for you. 1, 2, 3. That is reserved. Reserved. This was X. Reserved. This is Y. Then reserved. And this is going to be Z. And then 1 space is going to remain free. So now, the part of the computer memory which was free now is now left for has changed such that you have reserved 3 spaces in the computer which you have named X, Y, and Z, so that you can input data in those spaces. Mind you, you cannot put data here because this is not a reserved space for you. You can input data in this room, you can input data in this room, and you can put data in this room because you have already reserved them by virtue of int x, int y, int z. So now, what follows in programming is data entry or data inputting. You are now going to put data in the rooms, in the variables that you have reserved. You cannot put data here because you have not reserved it. You can put data into room X, you can put data into room Y, you can put data into room or variable Z. What does this, how does this relate to our bus sitting analogy? If you try to put data here, 1, you don't have name for this particular space, but 2, it means now you are going to a bus, you are entering in a bus without having a ticket with which you have reserved a seat, and that one is a recipe of chaos. So now when the computer comes at line number 9, it is reading x equals 4. What does this statement mean? This statement means that at room number X, which is this one here, number 4 should go there as the data. So now the situation changes such that we have this particular room X having 4. And then the rest, room Y, will remain reserved. And room Z will remain reserved. So that is as far as line number 9 is concerned. If you come to line number 10, that is y equal to 7, the computer will realize that you are commanding it to take data number 7 and put it into variable y. So variable x is already having 4. Now variable I will receive 7 because of this assignment which has taken place here. And this is a variable y. Then variable z will still remain reserved. And there is another variable here which is just free, as we have already said. So now when we come to line number 11, where the line is z equal to x plus y, what happens here? This is addition. The computer will go to room X and room I and take the content of room X and the content of room I. It will add this content and take the result to room Z. That is, in variable X we know there is 4. In variable Y there is 7. So 4 will be added to 7 and the result, which is 11, will be stored in variable Z because of this particular line. So what's going to happen in the computer, you find that 4, that is in X, and 7, which is in Y, will be added, and the result, that is 11, will be put in variable Z, while there is another variable which remains free. So now, by the end of this line number 11, this is the situation in the computer memory. So now, when it comes to room number 12, C out Z, this particular statement is asking the computer what is in variable Z. What is the content of room Z? In room Z, as we can see here, there is 11. So this particular statement will send number 11 on the screen, and return 0 will be the next line to be executed. This one is in response. It is a standard line which we use when we have declared the main function as an integer sort of a function. And for that matter, this is a standard line for the operating system to terminate this program properly. And at line number 14, that is the end of paragraph, and this is what we are going to see on the screen. So this is the runtime behavior of this program that you see here. We have tried to use these drawings and visualization in order to understand what is happening in the computer for each line of code that is executed. So we have used the RAM diagrams in order to analyze the behavior of our program.